want to make sure that we remember how to, like, when you're looking at this expression, what's the thing that we want to do? Starts with a D.
Distribute.
Distribute.
So, times.
What we do when you have an expression where you have a parenthesis and you have the 5 outside is you distribute it in, and what do you end up getting? What's this make?
Numbers.
Yeah, what is it?
10x plus 15.
That's it. And that's distributing.
Wait, no, that would be minus 15 because it's a negative.
Where's the negative?
Well, there's no number beside that parenthesis,
You just
so
make-
don't you put in a negative one?
Yeah, no.
He's
Now
making
you're making
sure-
things up. All
Just
right.
making sure you're paying attention.
Now, this is how we distribute. What you're going to learn today is how to undistribute. So the
What?
title is
You can
Factor the GCF, which stands for greatest common factor. Factor the greatest common factor from a quadratic expression. Now, a few things here, a few words here that we've never heard of, like quadratic. So what we want to do is make sure that we know what quadratic means.
for something.
Okay, so first note, a quadratic expression is going to be any math expression, any algebra expression where the biggest type of piece you have is a squared piece. So you will have something like, let's say 3x squared plus 2x plus 1. When we've been like multiplying those binomials, we've been making quadratics. You just didn't know what that was. It doesn't have to have all three pieces though. It could just be like negative 4x squared. It's quadratic because it's an x squared piece. Or it could be
Oh, I see, because 2x would make a...
minus x squared. Anything, as long as that's the biggest type of piece. You don't have any x3s, x4s, x5s, but you do have an x squared. And you could have an x and a number, or you could just have an x squared, or a number and an x squared. Just no x3s, x4s, and 5. That's what a quadratic is. So when we talk about factoring the GCF out of a quadratic expression, just expect when you're working these problems, you will have a piece that has x squared on it. All right, now here we get down to where we talk about factoring. All right, so the first type of factoring we're going to learn is going to be how to factor the GCF out of a binomial or trinomial. A binomial means how many pieces?
2.
2 pieces.
Dos.
And trinomial is what? Trinomial?
3.
3. So what you're going to see is this is the exact opposite. When I say factor the GCF out of a trinomial, or factor the GCF out of a binomial, it's the exact opposite of the distributive property. So let's start with this. Is this a binomial or trinomial? Binomial. Now, what I want to do is find some number that I can divide both of these by.
9.
Well, I can't divide that one by 9.
Oh, 3.
Oh, yeah, 3. Yeah, 3.
If I can divide both of them by 3, what I want to do is I'm going to take a 3 out, which means I'm going to write a big 3 and then a parenthesis.
3.
So it's the opposite of distributing.
Why wouldn't you do 1?
Well, one I could divide them both by 1, but that's not the greatest thing I can divide them both by.
Oh, okay.
Okay, so if I take a 3 off my x, it just becomes x. And if I divide or take a 3 out of my 9, it's like taking 9 divided by 3, which is what?
6.
3.
Oh,
3. If I did this right, if I undistributed right, I should be able to redistribute this and get that. So here's 3x, and here's 9.
Do I have to do that on a practice or anything? Like,
Yeah, this is objective 123.
you should give me that.
And I think
What's
you will see what some of them look like in a second.
What's 333 times 2?
Wait, what is it?
That's tough. That's
Wait, what is it? Hey, what did you say?
What's 333 times 2?
Hey, let's focus on what we got to focus on here.
I've been writing all this stuff.
All right, so here's our next one. Now this one says factor this. It's a binomial. What we want to see though, both pieces, we can divide a 4 off both pieces, right? So go ahead and put the 4. Don't put the parentheses yet, put the 4. I can divide this by 4 and I can divide this by 4. So we'll put a big 4. Put a big 4. Now don't put the parentheses yet, because you see how both pieces have an x. That means I can take an x off of both pieces as well. And so if I can take an x off both pieces, I'm going to put an x outside of the parenthesis with the 4.
X. Oh, okay, there's, okay, it's For x
But one of
squared,
them's
we
x
take one out.
squared.
Okay, so here's what happens.
Taking one out, there's only be two.
If I take the 4 off, there's no 4 left. But then I take one of these two x's off, and it just leaves me with just x.
Okay. I get you.
So 4 divided by 4 just makes 1. X squared divided by x, or x squared, take off 1x, leaves you with just x. And then you come to the second piece. 12, if you divide 4 out of it,
3.
you get 3. And then if you take 1x off of it, there's no x's left. And that's what we get. So here it is. This is 4x squared, and this is 12x if you redistribute it.
That's easy.
So just always make sure if you did it right, down here, if you did it right, you should be able to redistribute and get what you started with. 4x squared, it's right here, and this is 12x.
This ain't really hard.
It's actually really easy.
You just pay attention to when you're going to put the x out here and when you won't. This next one, you have a trinomial. So we are going to undistribute from a trinomial. So what we want to do is I got a 9, a 9, and a 45. And say, what's the biggest number I can divide those by?
5.
Okay, I can divide them all by 1. I can divide them all by 3. Because I can divide 45 by 3. Can I divide them by 9 though?
Yes.
Divide by 9, divide by 9, 45 will divide by 9.
Because that'd be 5.
So then 9's the biggest number. So put the big 9. I can divide all 3 things by 9. Now, when it comes to putting the x here or not, does every piece have an x on it? No, so then don't put the x. That's all you got to look at. If they all had like some sort of x, we would put an x here, but we don't. So let's just put the parentheses.
Oh, really? I wrote next that time.
All right, you take a 9 off of this, and what's that leave you with?
X squared.
Put that there.
But why wouldn't you use the 9x squared first?
What do you mean?
Why wouldn't you use it first instead of just the 9x?
Instead of this.
Because if you take off the 9 and an x, that's just.
Well, I'm just looking at the way it's written, where it goes 9x squared plus 9x plus 45.
That's what I'm saying. Why did you use the 9x and not the 9x squared?
I did use this one here.
Why is there a parenthesis in between the two?
Because
Yeah.
he's taking it off.
Yeah,
of
it's
it.
because, all right, we write the 9. I want you to write the 9 first.
I get 9 down.
Okay, and then just make sure if all 3 pieces don't have an x, then you're ready to put your parenthesis in. So you put your parenthesis.
Oh.
Now we're looking right here and going, okay, first piece, if I take a 9 off, what's left? X squared. Now the second piece, if I take a 9 off,
Plus 9.
not plus 9, plus,
X.
I'm taking the 9 off,
Oh,
so
plus-
just plus x.
Then
And then the third piece, you are going to divide. 45, if you
Plus
take 9
5.
off, that means divide 9 off. And what is that? 5. Once again, if done right, it should redistribute back to what we started. Here it is. 9x squared is here. 9x is here. And 45 is right there.
Okie doke.
calm yourself.
All right, we're coming down toward the end here. Now, this one is a binomial. And I've kind of already got it set up for you. But look, both of these can be divided by 5, right?
Yeah.
10 can and 15
But
can.
one of them's a negative.
But if the biggest one, if the squared one is a negative, what we're actually going to do is put negative 5. So I drop a negative 5 here. Now, why do I have a p here as well?
Because it's squared.
Because there's P on both.
Yeah.
On both pieces have a p. If I had a third piece that didn't have a p, I could not put it here. But 2 pieces, they both have a p. So let's put it here. All right. So first thing is, looking at this piece getting ready to go here. Negative 10 divided by negative 5 makes what? Negative 10 divided by negative 5.
Positive 2.
Positive 2.
Positive 2.
And then you had p squared, but I'm taking 1p off,
So 2p.
so just p. I have p squared, which is just 2 of them, and so I took 1 off. Remember, if you remultiply this should make negative 10p squared. It does. Now do this one. Take a negative 5 off, so 15 divided by negative 5 makes what?
Negative 3.
Negative 3, and then if you take 1p off it, there's nothing left. And that's what we got. So, that's negative 10p squared, and that's positive 15. Alright, to end it, take a minute, and let's look at both of these. Here's a binomial, here's a trinomial. See if we can figure out the GCF and factor it. Thumbed up here. All right, now, what's the biggest number I can divide both these by?
4.
4. I can divide them both by 2. That's okay, but that's not the best. That's not the greatest. 4 is. Before I put my parenthesis check, do they both have the letter C?
Yes.
So what does that mean?
Put a C.
Put a C, and then let's put the parenthesis here. 28 divided by 4 is
7. C
7,
squared.
and take 1 C off, so what's that leave you?
C squared.
Well, it was C squared.
C.
C.
All right, 16.
Plus 4.
Take 16 divided by 4 is 4.
Hey, you didn't put a line through your 7.
There we go.
Really
So I got 4C plus 4. That's 28C squared, and that's 16 C's. Now here's the hard one. Let's do the hard one.
What happened?
Oh, hit the
It's
lamp.
gonna give me a seizure.
Wait, you what?
Hit the lamp.
What did that do?
Just turn the light off. Now we're back on. Okay, so looking at this one. All right, between 14, 7, and 21. 14, 7, and 21. What's the best I can divide all of them by?
7.
-7.
7, but it's going to be negative because the leading piece is negative. So I'll put -7. Do I put a Q with it?
No.
No, why not?
Not all 3 of them have a cube line.
Yeah, no Q right here. So then let's just divide. -14 divided by -7 is?
-2Q. Squared.
Is it -2?
No, it's +2.
Positive, but it is Q squared.
Yes.
-7 divided by -7.
Plus Q.
Positive Q, and then -21 divided by -7.
Plus 3.
Or is this plus 3?
Yeah, just plus 3. If done right, real quick check with your mind. -14Q squared, -7Q, and -21. And that is it. That is called factoring out the GCF. I like to call it undistributing. That's one type of factoring that you'll have to do.